Picture this. It's a scorching summer afternoon, your AC is blasting, everyone's home streaming Netflix, and suddenly, the lights stay on. No blackout, no brownout. How? The answer might surprise you. It's massive batteries hidden away, working silently to keep our grid stable. Today, we're diving deep into battery energy storage systems, or BESS. And trust me, this isn't just some nerdy tech talk. This is about the backbone of our clean energy future. Ready? Let's go. So, what exactly is a BESS? Think of it as a giant rechargeable battery, but instead of powering your phone, it's powering entire cities. And here's where it gets interesting. Not all batteries are created equal. Right now, lithium ion batteries rule the roost. Why? Two words: electric vehicles. The EV boom has driven down costs and ramped up production like crazy. We're talking economies of scale that make these batteries perfect for grid storage too. But here's a fascinating split in the market. While your Tesla uses something called NMC chemistry, that's nickel manganese cobalt, the grid is going all in on LFP, lithium iron phosphate. Since 2022, LFP has basically taken over utility scale storage. Why the switch? Think about it this way: EVs need to be light, so energy density is king. But for grid storage, who cares if your battery weighs a few extra tons? What matters is safety, longevity, and cost. And LFP absolutely crushes it in all three categories. We're talking superior thermal stability, longer life, and a lower price tag. It's a no-brainer. Now, lithium ion is fantastic for short bursts, up to about 4 hours. But what if you need to store energy for an entire day? Enter flow batteries, specifically vanadium redox flow batteries, or VRFBs. These are wild. Instead of solid electrodes, they use liquid electrolyte solutions. And here's the game changer: you can separate power from capacity. It's like having a water tank. Want more water? Make the tank bigger. Want it to flow faster? Get a bigger pump. Same principle here. Sure, VRFBs have some trade-offs. They're bulkier and they're about 5 to 10% less efficient. But, and this is huge, they have an almost unlimited cycle life. They're non-flammable. And here's the kicker: because they're so safe, you can stack them vertically. That means smaller footprints in expensive urban locations where lithium-ion installations would need to be spread out for safety. And the innovation doesn't stop there. Solid-state batteries promise even higher density and safety. Sodium-ion and zinc-air batteries are coming for large-scale, long-duration applications. The future of grid storage? It's not one size fits all, it's a toolbox, with the right battery for every job. Battery Energy Storage Systems, or BESS, the unsung hero of the energy transition. From lithium-ion workhorses to flow battery innovators, from smart energy management to grid-saving ancillary services, from falling costs to circular economy solutions, BESS is reshaping how we generate, store, and consume electricity. Here's where BESS really shines: grid support. Modern grids with lots of solar and wind are inherently unstable. The sun doesn't always shine, the wind doesn't always blow. BESS fixes that. Frequency regulation: BESS responds in milliseconds. When there's a sudden drop in generation or spike in demand, BESS can inject or absorb power faster than any conventional power plant. We're talking fast frequency response and primary frequency response, keeping the grid stable at exactly 60 Hz. Voltage support? Same deal. By injecting or absorbing reactive power, BESS keeps voltage levels consistent, preventing the brownouts and blackouts that plague unstable grids. And of course, the big one: renewable energy integration. BESS transforms intermittent solar and wind into dispatchable power, smoothing out fluctuations, firming capacity, shifting energy from when it's generated to when it's needed. Without BESS, high renewable penetration is basically impossible. With it, we're building a clean energy future. Let's talk money. The reason BESS is exploding isn't just environmental, it's economic. Battery costs are plummeting. According to projections from the National Renewable Energy Laboratory, utility-scale BESS costs will continue dropping significantly through 2050. In conservative scenarios, we're looking at 18% total reduction from 2022 to 2035. In advanced scenarios, 52%. That's over half the cost, gone. And here's what's interesting. Longer duration systems are getting cheaper faster than short duration ones. Eventually, they all trend toward the same low cost baseline. But here's the thing, even with falling costs, single application BESS rarely makes economic sense. The magic is in value stacking, providing multiple services simultaneously. Arbitrage plus frequency response plus capacity firming. Stack them together and you don't just add revenue streams, you create synergies. Research shows stacking services can double the profitability of the best standalone service, but it requires sophisticated modeling and algorithms to pull off. Here's the real story. BESS makes renewable energy actually work. Without storage, solar and wind are unreliable. With it, we're building a clean, stable, flexible grid. The bottom line? BESS isn't just another piece of infrastructure. It's the missing link between renewable generation and reliable power. It's what transforms our energy future from a dream into reality. Thanks for watching. If this sparked your interest, subscribe and let me know what energy topic you want explored next.